Hello all, welcome to vStudent blog. This is the VMware vSphere introduction training video. In this video we'll be knowing about what is vSphere, why we use all stuff. So let's start. So what is VMware vSphere? So VMware vSphere is a cloud virtualization platform capable of running full-scale virtual machines and Kubernetes instance for scalable cloud hosted applications. And why do VMware vSphere matter? So vSphere is the most popular data center virtualization platform in the industry, and also the third party support surrounding network, compute and storage and other solutions too. So why does VMware vSphere affect? So vSphere is a data center product supporting solutions that include storage, network, compute. So IT infrastructure practitioners should a stay abreast of the changes in the vSphere and the ecosystem. So when was you may have a question, when was this vSphere released? Originally it was released in 2009. So the current version is 8.0. So we were talking about VMware vSphere in depth. It is a software suite that includes components like Esxi, hypervisor, vCenter server, vSphere client, web client, vCenter or orchestrator, vSphere update manager, and vSphere components provide virtualization management, resource optimization and many other features useful for an virtual environment. So vSphere is used to virtualize and aggregate the underlying physical hardware resource and to provide the pool of virtual machines, virtual resources to the data center. It also provides some advanced virtualization features such as uh, DRS, HA. DRS is a distributed resource scheduler, high availability, fault tolerance, etc. and more. Even we have vMotion, storage vMotion, lots more. So like a vSAN. So uh, mm, people new to virtualization platform sometimes get confused in dealing with vSphere and its components. So remember that vSphere is a suite of products just like MS Office, which contains Word, Excel, Access, PowerPoint, like that. So vSphere also a pack of lot of components. So why we virtualize? What is the advantage? So there are many reasons why should we consider to be virtualized the environment. So here are some. So server consolidation. So virtualization can help you conserve physical space in traditional data center environments. It is common to dedicate each server to a single application. This leaves most computers vastly underused. So using a single application on a server, for example, it is consuming only 15% of the resources. Remaining 85% is not used, and it's waste of resources. So virtualization enables you to run more workloads on single server, which reduce the number of physical servers in your environment. Like if your data center have less servers, obviously you pay less for the power supply, less for the less for the space, everything so that definitely matters. So reduce cost. So hardware is most often the highest cost in the data center because virtualization reduces the need for the physical machines. The cost also goes down, but the cost goes well beyond that of the hardware. Software licensing savings, power and cooling cost reduction, improved user accessibility and performance are also some of the ways to reduce your cost. So increased uptime. So VMware offers a number of advanced features that are not available on physical servers, which help with business continuity and increased uptime. Such capabilities are live migration, that is vMotion, storage migration, fault tolerance, high availability, etc. These technologies keep virtual machines running or give them the ability to quickly recover from unplanned outages. The ability to quickly and easily move a virtual machine from one server to another server is perhaps one of the greatest single benefits of virtualization with for reacting users. So next is faster server provisioning. With VMware, you can quickly clone an image and master the template or existing VMs to get a server up and running within minutes. It is contrast to physical servers, which usually requires hours for installation, and placing an order for a physical server, it will take months also. So simply clicking on a template and creating a VM take not even 2 or 3 minutes, and you can using scripts. You can you can build hundreds of servers in minutes. So next is easier backups. With virtualization, you can create full backup of your virtual machines within minutes. These backups can be moved from one server to another and redeployed easier and faster. You can also take a snapshot of the virtual machine, which is state of the virtual machine at a specific point in time. So in virtualization, physical resources are shared among virtual machines. Resource sharing represents perhaps the most significant advantage of server virtualization, because you can allocate resource to an VM based on the machine's actual performance needs. Multiple virtual machines can run on the same physical host, with each virtual machine sharing the resource of the host. Virtual machine shares access to CPU, physical network cards, disk controllers, and are assigned their own region of memory. On the same physical host, different virtual machines can run different operating systems. For example, you can run virtual machines that run some Linux distributions and virtual machines that run Windows on the same host. When multiple virtual machines runs on the same host, each virtual machine is allocated a portion of its physical resource. Hypervisor allows multiple operating system to share a single hardware host. So these are the components. I will give a brief on each of these. We already discussed, but let me take you one on one. So Esxi hypervisor is a type 1 hypervisor. So hypervisor is a piece of software that creates and runs virtual machines. In vSphere, virtual machines are installed on Esxi servers, and Esxi servers are installed on physical servers. Okay, so these are connected to network and NAS or DAS or storage where all ESX are connected to this using the fiber channel connected to the storage devices to share the storage between them. And next one is vCenter server. In previous versions, we used to have Windows based virtual vCenter servers, and as the version changes, VMware removed the Windows based virtual machines, which saves the licensing cost, and even database also, like inbuilt database for the new VCSS virtual server appliance. So it is saving one is a Windows license as well as database license. So vCenter server is a centralized management platform and framework that lets you manage virtual machines and ESXi hosts centrally. So using the central console, you can manage entire your virtual environment. So you can create VMs, delete VMs. So you can create you can vmotion the VMs, vmotion the storage VM, like a lot more you can do using the vCenter server. So next is vSphere update manager. So before that, ESXi and vCenter server do have licensing, and they do have types of licenses like standard edition, enterprise edition, enterprise plus edition. We will discuss in the upcoming PowerPoints. So next is vSphere update manager. Update manager is like an add-on package for vCenter server that helps you keep your ESXi hosts and virtual machines patched with the latest updates. So virtual machine patching is like something I need to say that you can update the VM tools using the update manager. So patching VMware OS level for VMs was removed. So now we can update VM tools using the update manager, and we can update or patch ESXi servers using the update manager. So it is a built-in tool. Previously it used to be an additional installer for Windows servers, but latest version of VMware vSphere, it is integrated. So a vSphere web client, a web-based user interface used for managing a virtual infrastructure. So previously used to have an vSphere client agent, but that was removed, and now we have only web-based client as using the vCenter server slash UI. You can access the vCenter server, and you can like you can integrate with, you have to integrate with the Active Directory, and you can use the Active Directory login to log into the web to the vSphere web client. So HA is high availability. So high availability is configured on a cluster. Cluster is nothing but a group of ESXi boxes together in a single cluster or multiple clusters. Each cluster will have multiple ESXi boxes, where you can enable high availability DRS on a cluster. So enabling the high availability, what happens is whenever a ESXi goes down or due to some hardware issue, it gets failed immediately. So the HA will migrate the all ESXi, all the virtual machines on that failed host to the other host, and they will it will reboot the virtual machines. So HA is available in enterprise edition of license of vCenter server. So if you go for standard edition, it won't be available. Whereas the distributed resource scheduler, so it's available in a default standard edition. So HA is how it works is like it will elect the master master for the cluster, and master will deploy a log or a algorithm on all ESXi boxes, and it will be connected through network as well as storage paths, and a heartbeat is created, and it will check every few seconds. Whenever ESXi is not reachable, immediately master will take the initiation, and it will move the ESXi move the virtual machines to the other ESXi boxes. So that's how HA works. So initial stage it was called as AAM agent, and after that that was changed as FDM, fault domain manager. So it used AAM like like used to use only one path, that is network path. So after FDM was introduced, it started using two paths. One is network path and one is through storage. So distributed resource scheduler is like it will take care of migrating or vmotioning the virtual machines whenever a ESXi box is running on high memory utilization or high CPU. So whenever it will check the resource availability on the other ESXi box, and it will take care of migrating the virtual machines to other ESXi boxes without any outage or without any impact. So using the vmotion, DRS will do that. Vmotion is nothing but when a shared storage is there in between the ESXi boxes, you can migrate the virtual machines using right click on the virtual machine, and you can migrate you can vmotion the VM to other ESXi box. And even if you don't have storage, shared storage, then you can power off the VM and we can migrate. So as in the production we will be having a shared storage, so obviously we don't have that issue. So SVMotion is nothing but a storage vmotion, where you can migrate the virtual machine disks from one storage to another storage, so without any impact or without any server down. So next is fault tolerance. Fault tolerance is nothing but creating when you enable the fault tolerance, it will create a secondary machine on other ESXi box, and it will create a heartbeat between the primary ESXi primary VM and secondary VM, and it will be like it will be syncing simultaneously at a time. And if primary VM goes down, the secondary VM will convert it to primary, and it will create another secondary VM on another ESXi box, and the primary VM which is having issue went down, that will be turned off, and you can delete that one. So fault tolerance have some limitations, so most of the time very few people will use that, but for high critical machines you can use the fault tolerance. vSAN is like is vSAN is like vSAN will use the local data stores of the ESXi boxes, and it will create an single data store, and you can use the like for example each ESXi is having 100 GB of storage. If you enable vSAN, it will add all 100 like 4 ESXi boxes, it will make it as 400 GB, and as a single data store, and you can use that as a shared data store. And if one ESXi goes down, it will take care of it will manage and take care of the availability. So there is some limitation where if more than 2 ESXi goes down, based on the number, availability will be there. So next is VMware snapshots. So snapshots are like a one time snapshot at a time of a one time snapshot, which which can be used as a temporary, just for temporary backup. It's not a backup, but like if you are updating anything, if you take a snapshot, what happens is if something goes wrong, you can restore it immediately. So snapshots are two type. One is quasi state snapshot, and one is normal snapshot. So quasi state is like not at the time of snapshot, if you enable quasi state, it will take the snapshot of memory too, and when you restore the snapshot, the VM will be in a power on state where you took the snapshot. When if you doesn't take the quasi doesn't enable the quasi state, when you restore it, the VM will be in power off state, and you need to power it on. So snapshots, if a VM is having a snapshot, then what happens is you can add a space, or you cannot add a memory or CPU when it is in power when a snapshot exists on a virtual machine. So these are some components which we discussed, and upcoming videos we'll be working on each and every components, and it will be explained in depth and briefly. So talking about what is CPU virtualization, these are the few, where if you see here, this is the physical server on which ESX hypervisor has been installed, and this hypervisor CPU will be used as a vCPU for each of these each of these virtual machines, and so CPU virtualization involves a single CPU acting as if it was multiple separate CPUs. The most common reason for doing this is to run multiple different operating systems on one machine. CPU virtualization empathizes performance and run directly on the available CPU whenever possible. The underlying physical resources are used whenever possible, and the virtualization layer runs instructions only as needed to make virtual machine operate as if they were running directly on a physical machine. So when many virtual machines are running on ESXi host, those virtual machines might compete for CPU resources. When CPU contention occurs, the ESXi host time slices the physical processors across all virtual machines, so each virtual machine runs as if it has its specified number of virtual processors. So it is called like something nested virtualization. So whenever physical server, when you install ESXi hypervisor, so you have to, if you see here, with the VT virtualization technology and without VT, so you see the difference, like it is sharing the CPU and memory. Here you have some can, so some issues here. So like this is about CPU virtualization, and next is physical and virtualized host memory. So in a non-virtual environment, the operating system assumes it owns all physical memory available. When a when application starts, it uses interfaces provided by the OS to allocate or release virtual memory pages during the execution. Virtual memory is a technique used in most operating systems and is supported by almost all modern CPUs. Virtual memory creates a uniform virtual address space for application and allows the OS and hardware to handle the address translation between the virtual and physical address space. This technique adopts the execution environment to support large address spaces, process protection, file mapping, and swapping in modern computer systems. In VMware vSphere environment, the VMware virtualization layer creates a continuous address memory space for the virtual machines when it is started. The allocated memory space is configured when the virtual machine is created and has the same properties as the virtual address space. This configuration allows the hypervisor to run multiple virtual machines simultaneously while protecting the memory of each virtual machine from being accessed by others. So all these taken care by VM tools, like whenever you install a virtual machine, VMware tools on the guest operating system, it will take care of memory allocation, all stuff using the virtual memory ballooning driver. So this is some figures which I took it to make it understand easy for you guys. So next is physical and virtual networks. So the key virtual networking components in virtual architecture are virtual Ethernet adapters and virtual switches. A virtual machine can be configured with one or more virtual Ethernet adapters. A virtual switch enables a virtual machine on the same ESXi host to communicate with each other using the same protocols used over physical switches without the need for additional hardware. So that is these ports are called port groups, and VMware technology lets you link a local virtual machine to each other and to the external network through a virtual switch. So whenever you install ESXi box, it will automatically creates its own virtual switches on the which connects to physical switch. So a virtual switch, just like a physical Ethernet switch, forwards frames at the data link layer. An ESXi host can contain multiple virtual switches. The virtual switch connects to the external network through physical Ethernet adapters. The virtual switch is capable of binding multiple virtual network cards together, offering greater availability and bandwidth to the virtual machines. Virtual link switches are similar to modern physical Ethernet switches in many ways. Like a physical switch, each virtual switch is isolated and has its own forwarding table. So every destination the switch looks up can match only ports on the same virtual switch where the frame originated. This feature improves security, making it difficult for hackers to break virtual switch isolation. So going in depth about virtual switches, virtual chip, like this is the virtual switch. When you open the vCenter, you'll be able to see like this, which connects to the physical adapter. So but VMware has designed the vSphere suite to mimic the function of physical network. So a lot of the network hardware you will find in the real world, you will also find virtualization in vSphere, which is virtualized in the vSphere. Virtual switch work very much like the physical counterparts Ethernet switches, but lack some of their advanced functionalities. They are used to establish a connection between the virtual and the physical network. A virtual switch can detect which virtual machines are logically connected to each its virtual ports and use that information to forward traffic to the current virtual machines. A virtual switch is connected to virtual switches by using physical Ethernet adapters to join virtual networks with physical networks. So the major role is to connect the virtual machines to the physical adapters is virtual machine port groups. Post, these ports used to connect virtual machines to virtual other VMs or the physical network. So this is VM kernel ports. So ports configured with their own IPs, subnet, mask, and default gateway to allow hypervisor management traffic. vMotion Esxi storage access, sorry, network attached storage, that is NAS, and vSphere FT, that is fault tolerance. So we need to configure these when we configure the virtual port groups, VM kernel port groups. So this is about virtual switches and types of switches. We have two types of switches in VMware environment. That is standard switch. So a standard switch that is a V switch. We call it as V switch. Is created by default when Esxi is installed, like its physical Ethernet counterpart. A standard switch works at layer 2, forwards frame to other switch ports based on the MAC address and supports features such as VLANs and port channels. Standard switches has to be connected to the Esxi host physical NICs as uplinks to communicate with the result of the rest of the network. They are configured at the high host level, meaning that you must create and manage a vSphere standard switch independently on each host. So it's like if you configure standard switch in your environment, it means whatever changes you do on vSwitch, that will be independently applicable to the particular Esxi host. For example, if you create a VLAN, it will be applicable to this Esxi box, and you need to go to next Esxi box, create the same VLAN, and again same VLAN on this. Like that, if you have 1000 Esxi boxes, you have to do that job 1000 times. So which is really painful. So to overcome that, we have a distributed switch. So distributed switch is like talking about that a distributed switch functions as a single virtual switch across all associated Esxi hosts and allows virtual machines to maintain consistent network configuration as they migrate across multiple hosts. Just like standard switches, distributed switches forward frames at layer 2 support VLANs, NIC teaming, outbound traffic shaping, etc. The biggest difference between these two of these V switch and DV switch are configured using a centralized unified management interface through vCenter server, which greatly simplifies virtual machine network configuration and reduces complexity in clustered Esxi environment. Distributed switches also support some advanced networking features like IO control, port mirroring, network health check, and support for protocols such as NetFlow, PV-VLAN, that is private VLAN, link aggregation control, that is LACP, and the link layer discovery protocol, that is LLDP, etc. So but the main drawback is the distributed switch comes with enterprise edition, and the standard switch comes with default standard edition. So if we don't have an enterprise edition, then you cannot use this benefit of distributed switches. So that's about the switches. And next is VMware vSphere VMFS. So VMFS is a virtual machine file system. So VMware vSphere VMFS physical file systems usually allow only one host to have read-write access to the same file at given time. By contrast, VMware vSphere VMFS enables a distributed storage architecture that allows multiple ESX hosts concurrently read and write access to the same shared data store or data storage resources. VMFS is optimized for a virtualized environment and offers a high performance cluster file system designed specially for virtual machines. It uses distributed generaling for its file system metadata changes to allow fast and resilient recovery in the event of an hardware failure. VMFS is also the foundation for distributed infrastructure services such as live migration or virtual machine and virtual machine files dynamically balance workloads across available compute resources, automated restart of virtual machines, and fault tolerance. VMFS provides an interface to storage resources so that several storage protocols like fiber channel over Ethernet, NAS, over Ethernet, NAS, Esxi can be used to access data stores on which virtual machines can reside. Dynamic growth of VMFS data stores through aggregation of storage resources and dynamic expansion of VFS data store enables you to increase a shared storage resource pool within no downtime. In addition, you have a means for mounting a point in time copy of data stores. So, um, like as the version of vSphere changes, even VMFS version also changes and giving more advantages. Talking about the licensing, we have three licenses, that is standard, enterprise, and enterprise plus. So talking about that, we are talking about the VMware tools, like we're talking about the CPU sharing, memory sharing, like all these. So VM tools is a major part in that. Is a suite of utilities that enhances the performance and improves management of the virtual machines. Guest operating system, it is not installed by default. Yes, whenever you install a virtual machine, what happens is it comes with default things. You need to mount the VM tools and you need to install the VM tools. So before that, moving a mouse is like a pain, really pain. And the drivers for VMX3 is not installed till the VMware tools are installed. So like you can see here what are the benefits here, like optimized NIC drivers, optimized KC drivers, virtual machine heartbeat, enhanced graphics and mouse performance, time sync, ability to shut down. So without VM tools, if you try to shut down a VM, soft reboot or soft shutdown from vCenter, it will say VM tools not installed and it's failed to do that. Once you install the VM tools, you will be able to shut down or restart the virtual machine. Better memory management using the memory billioning driver. So the following comments are installed when you install VMware tools, like VMware tool services, VM tools d.exe on Windows guest, or tools d on Linux. This service synchronizes the time in the guest operating system with the time in the host operating system. A set of VMware drivers, device drivers will be installed. If you install the VMware drivers, you will be able to see a lot of memory, what do you call that, display drivers, mouse drivers, everything will be installed. So every time VMware releases the new drivers, VMware tool drivers, whenever you install a new Esxi, whenever you upgrade to new Esxi version, the VMware tools also will be the native VMware tools will also be updated on the Esxi box, and you will be able to see on VM that your VMware tools are outdated and need to upgrade. That's what the alert pop-up on all virtual machines, and you need to update the new tools. So, and a set of scripts that helps you to automate guest operating system operations. The VMware user process, VMware Esxi on Windows guest, or VMware user on Linux guest, which enables you copy paste text between the guest operating and the host operating system. So yeah, like when you try to copy paste something, if VMware tools is not there, it won't allow you. So this is the overview and some introduction about the VMware components, VMware tools, and other stuff. So going forward in the next video, we'll be seeing how to install ESXi server, how to download ISO from the VMware site, how to install vSphere, vSphere server, then how to create a VM, how to create vMotion, how to create network port groups, how to create a distributed switch. All stuff we'll be discussing, and also we'll be discussing about the some issues interview questions, known issues, everything will be discussed in upcoming videos. uh, and I believe this video is informative for you guys. Thanks for watching. Please do subscribe and like my videos. Your subscription, if your subscription likes make to make more videos which will be helpful for you guys. Thank you very much. For any queries and suggestions, you always reach out to me on vstudentblog@gmail.com. Thank you. Bye bye.